Hi, welcome to Architecting with Google Cloud. I'm Gabe Weiss. Shared file storage is the unsung hero of application development. Pick the right solution, chances are no one's going to notice. But pick the wrong solution and you'll be chasing bottlenecks for days. No one knows this better than our partners over at Netapp. And today, I've got Oliver Krause, technical marketing engineer from Netapp, to tell us about a great solution for Windows file sharing. Oliver, why don't you take a second, introduce yourself, and tell us a little bit about what you and Netapp do.
Hi, Gabe. Thanks for having me. So I'm Oliver, located in Germany, near Munich. Over 20 years ago, I started at a storage startup called Netapp. It became a unicorn, and today it's one of the biggest storage and data management companies in the world. I held many different positions in that company, usually in pre-sales positions, helping customers solve their storage problems. And a few years ago, I switched into our cloud business simply to help do new stuff in the cloud world.
Glad to have you. So, Oliver, I've got a Windows application and I want to run it in the cloud, but I know there are a ton of file storage solutions out there. Maybe you could tell us just a little bit about what's out there and some pros and cons.
Yeah, in the storage world, we have three different kinds of storages. The first one is a traditional disk, like a hard disk or an SSD or USB stick. It's basically a disk which you plug into your computer, put a file system on top of it, and use it locally. It's also called block storage. After some time, people thought, it would be cool if we could use that file system on that disk on multiple computers, so share the data. And don't share it on a disk base, but share it on a per file base. So basically, and file sharing was invented. Some file sharing file systems were invented, and people were able to use data on multiple VMs or multiple computers in that time. And the new kid on the block is object storage, like Google Cloud Storage. It uses HTTP to store data, relatively new, let's say 10 years or something. And it's a great way to store unstructured data, but most of the enterprise applications in enterprise data centers still don't talk object, but they talk file, NAS, to share data.
Right, so people just say, just lift and shift. It's so easy. But clearly, if your application doesn't speak object storage, that's not going to be so easy. So you've been around. What specific challenges have you seen in terms of shifting a Windows application up to the cloud?
Okay, so let's assume we want to do a lift and shift with a Windows application. And that application requires data sharing between multiple VMs, which is, by the way, a very common scenario. To enable that, you first need to deploy a GCE instance with Windows, the operating system, running. You need to size the VM correctly. Eventually, you have to patch it, keep up with the latest patches. You have to monitor it. Maybe the performance requirements change, so you have to resize it. You have to think about backup and recovery, and maybe even make it high available, so multiple zones and so on. And after you did all of that, you can start to attach a data disk, put a file system on top of it, and share it via the SMB protocol to other machines.
So hang on, you mentioned SMB. Some folks might not necessarily know what SMB is. Could you just explain real quick what that is and maybe compare it to what folks might be more familiar with, like NFS?
Yeah, so to share out the local file system, which is on a disk in a computer, if you want to share it out to different computers, you need a protocol to access the file system over a network. In the old days, most systems have been Unix, and NFS was invented, Network File System, which is still used in Unix-based or Linux-based systems today and very popular. In the Windows world, Microsoft invented SMB, which is an abbreviation for Server Message Block. In the beginning, it was not a very good protocol, but anyway, in the 2000s, Microsoft renamed it to CIFS, which stands for Common Internet File System. Everything had to be named Internet something. Later on, Microsoft renamed it back to SMB. Today we have SMB version 2.1 and very recently 3, which are very good and capable protocols.
Got it. And I know Cloud Volume Services, or CVS for short, supports both SMB and NFS. So this leads nicely into what we want to talk about today. So to start, why don't you just tell us, what is CVS?
CVS is NAS shares as a service. You create a volume and share it via NFS or SMB or both to your clients. And since it's a service, it's super easy to use and to consume and trouble-free to manage.
And how does CVS help us specifically with like a Windows migration, for example?
Yeah, like I said, if you do it with a Windows way, you have to manage a Windows VM with all the adjacent problems. CVS, in contrast, is a service, so you can easily create volumes, you can scale them up and scale them down, both capacity and performance-wise. Just you pay per gigabyte per month, just like you do with persistent disks and GCS. You get a bill from Google instead of Netapp because it's built through Google. Google takes your support calls, so it's supported by Google. And additionally, we have snapshots built in, and these snapshots are different from the persistent disk snapshots you might be used to. So let me quickly elaborate on these snapshots and give you 3 use cases. These snapshots are instant to do. Within a second, you created a snapshot, which is basically a photo of your file system. You can do multiple of them, and with that, you can build a history of your file system, like a versioning system. And the first use case, let's assume you want to upgrade an application and you're concerned that this upgrade might fail and it changes your data and you're left with an unfinished upgrade which changed your data. You simply do a snapshot, which is super fast. It's like creating a backup in a second. You do the upgrade. If it works fine, delete the snapshot afterwards. If it fails, you have the snapshot and can easily restore your data to the last known good state. The second use case, which is likely the most relevant one for a lot of customers, is you can enhance your backup and recovery processes with snapshots. Simply build a snapshot schedule which takes a snapshot every day for the last few weeks. And if you delete a file, you can simply go back to that snapshot with a Windows File Explorer. So the user itself can do it in the UI. They can simply go in there and identify the last good version of the file and restore it back to their file system. So it helps them avoid a help desk ticket, and nobody likes help desk tickets, right? And the restore is much, much faster. And you can even go beyond that, since snapshots are so lightweight and cheap to do. Simply take them every hour. Take hourly snapshots. And if you now delete a file, you not only get the version from yesterday, from the nightly backup, you can get the version from last hour, which is way more current. So that's a super cool functionality to reduce the recovery point objective. And the last use case, since we are talking Windows operating systems here, the issue with Windows is we are in danger that ransomware infects them and encrypts all the files on your disk. Since you have snapshots, you can take them every hour or so, and you have a very recent known good state where your files not have been infected. And the cool thing is you can really quickly restore that files individually, or you can roll back the whole volume within few seconds, half a minute or so. You can roll it back to the state of the last known snapshot and basically delete all the encrypted files by that. Super cool. And last thing, it doesn't matter how big your file system is, be it a terabyte or 100 terabyte, the time it takes to create a snapshot or roll back a snapshot, it's all the same.
God, these snapshots sound really cool. Can you like make copies of them? Can you clone them into like other applications?
Yeah, you can simply create a snapshot of a volume and then create a new volume from that snapshot. And by the way, this process also takes a few seconds. Let's say you are done in half a minute or less.
Yeah, so the developer in me is imagining, as you're talking, it kind of popped into my head of, we oftentimes as application developers run into a situation where you've got a very specific configuration of files on disk that reproduce a problem for your applications. And sometimes reproducing that is kind of hard. But if you're making these snapshots, I can imagine a place where you get a file, a file system set up where it reproduces the problem. You snapshot it so that you can make changes and then reset to be able to reproduce the problem. That's super cool. So Oliver, I'd love to dive in a little bit deeper here. Could you walk through maybe where we can find it and then a use case or two where we'd want to use it?
Yeah, the good thing is it's directly built into the GCP console. Just open the GCP console, search for cloud volumes, and it's there. It's also on the left side. If you look up all the services, you will find it down at the bottom under Partner Services. You will also find the documentation and the Cloud Architecture Center on cloudgoogle.com. Regarding use cases, I want to present two. The first use case is a pretty generic architecture which is used on thousands of legacy applications. You have multiple GCV VMs running Windows applications, and they need a file share to share data. So what you do is you simply provision a CVS share and map it to the Windows systems. And we have multiple examples where this applies. The first one would be, for example, VDI, Virtual Desktop Infrastructure, where you have SMB shares for the user home directories, for group directories where people share data between multiple users, and for the profile shares. Another one would be automotive and manufacturing. They're running a lot of computer-aided design and computer-aided engineering applications. Most of them want to talk to a file system to share data. So an SMB share is the way to go here. And that applies to many other industry verticals. And the last one I want to mention is media and entertainment. More and more we see that these people have geographically dispersed teams working together on a project. And they all need to access the same data, the same media assets in a performant and consistent way. To aid these requirements, we have a solution called Global File Cache, which builds on top of Cloud Volume Service. It helps you to share out a share globally to all the different sites, for example, LA, London, Singapore, while retaining access performance over the WAN network. On the other side, minimizing traffic to reduce costs and enabling global file locking to avoid conflicts when multiple users try to modify the same file at the same time.
This is all really great. Thank you so much, Oliver, for being here today and talking through this great partnership between Google Cloud and Netapp using SMB file share on Windows for Windows application development. It's really been a pleasure having you here.
Yeah, my pleasure. Thanks for having me, Gabe.
And if you all out there want to dive in right away, we've got links in the description below to some more great content to see this in action. If you all have any more ideas for customer stories or architecture that you're interested in learning more about, let us know in the comments. And if you want to see more of this kind of content, click the like and subscribe buttons. See you next time.